Hello everyone, welcome back to Physics Online CET classes for class 11 and 12 standard students. Let us continue the chapter Units and Measurement Part 4. You can remember in the previous class we completed nearly 110 multiple choice questions on the same chapter, and today I am going to solve applied multiple choice questions. So now we can solve applied questions on the topic measurements and significant figures. The first question, unit of specific resistance is in second PUC you are going to study about resistance, resistivity. Resistivity is also called as a specific resistance. See here, resistance depends on length and area. R equal to L divided by A. So we can write R is directly depending on length of the wire and resistance is indirectly or inversely proportional to area of cross section of the wire. So here we can write R is equal to proportionality constant. We can write rho L divided by A. So this rho is called resistivity, or we can also call it as specific resistance. So the equation becomes rho equal to R A divided by L. SI unit of resistance is ohm. Area SI unit is meter square divided by SI unit of length is meter. So here meter and meter will get cancelled. So the SI unit of resistivity or specific resistance is ohm meter. So ohm meter is the SI unit of resistivity, or which is also called as specific resistance. So option C is right. Second question, the unit of Stephen Boltzmann's constant is. Here we have to find what is the unit of Stephen's Boltzmann constant. See here, we have the equation for Stephen Boltzmann constant. I am going to write E is equal to sigma A T raised to 4, where E is the energy dissipated per second. What is E here? Energy dissipated per second. Energy dissipated per second, that means here it is equivalent to power. What is power? Power is rate of doing work. P equal to W by T. W is what? Work done, which is equal to energy. Energy dissipated per second. E indicates energy dissipated per second, or instead of E we can write power P equal to W by T. Here the above equation, this equation can be written as sigma equal to E divided by A T raised to 4. Sigma equal to energy is equivalent to what here? Energy dissipated per second. So here the unit of energy dissipated per second is what? Watt, divided by area is measured in terms of meter square and temperature is measured in terms of Kelvin. So Kelvin raised to 4. So what is the unit of sigma here? Sigma is measured in terms of watt per meter square, Kelvin raised to 4. Then what is the sigma? Sigma is Stephen Boltzmann's constant. What is the equation here? E equal to sigma A T raised to 4. About Stephen's Boltzmann constant you are going to study in the chapter Thermal Properties of Matter. So the right answer is watt per meter square Kelvin raised to 4. Option A is right. Third question, unit of self-inductance is. Self-inductance, you are going to study in the chapter electromagnetic induction. See here, the equation is given by E equal to L di over dt. Or we can write L equal to E divided by di over dt. So here this L indicates the self-inductance or coefficient of self-induction. L indicates self-inductance and the equation is L equal to E divided by di by dt. Now we can write its unit. So here E indicates EMF. EMF means potential difference. So the unit of potential difference is volt divided by di divided by dt. So we can take ampere over second. The unit of current is ampere and the unit of time is a second. Or we can write here volt into second divided by ampere. Volt second per ampere. Right? Then instead of volt, because here volt is the unit of potential difference, we know that 1 volt. How to define 1 volt? 1 volt is potential difference between two points in a current carrying a conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the another. So we can write 1 volt can be written as joule, 1 joule per 1 coulomb. Right? That means W divided by Q. Work has to be done to bring a unit positive charge from one point to another point. Work is measured in terms of joules and charge is measured in terms of coulomb. So instead of volt, we can write joule per coulomb. Now this equation can be written as, instead of volt, what we can write here? Joule per coulomb into second divided by ampere. Right? So this is the unit for self-inductance. Now you can observe the options. Which is the right option here? Joule per coulomb into second divided by ampere. So option B is the right answer. Fourth question. The unit of permittivity of free space epsilon naught is. The unit of permittivity of free space. See here, the equation we studied in electrostatic, you can observe electric force F equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So using this equation, we can find the unit for permittivity. You can observe here the symbol epsilon naught. This symbol indicates absolute permittivity or permittivity of free space. We have to find the unit of epsilon naught. See here, this equation can be written as, I am going to write F equal to 1 divided by 4 pi epsilon naught capacities Q1 into Q2. Suppose if I am going to consider Q1 and Q2 both are having the same charge Q. So Q into Q divided by R square, or we can write 1 by 4 pi epsilon naught Q square divided by R square. But here we want the unit for permittivity. So this equation can be written as, see here I am going to write epsilon naught is equal to, the equation becomes Q square divided by 4 pi R square into F. Epsilon equal to what? Q square divided by 4 pi R square into F. Now easily we can write the unit for epsilon naught. Q indicates a charge. The unit of charge is coulomb. So here this is coulomb square divided by 4 pi. This is constant. Leave it. R square. R indicates distance or the position vector or the radius. It is measured in terms of meter square into force is measured in terms of Newton. So what is the unit? Coulomb square. You can observe here coulomb square per Newton meter square. Coulomb square per meter square Newton or Newton meter square. So that indicates option D is the right answer. Question number 5. If unit of length and force are increased 4 times, then the unit of energy is. Here the question is the unit of length and the unit of force. If they are increased 4 times, then what about the unit of energy? See here, we know that work done is given by the equation force into displacement. Right? So work done unit, let us take it as, we can take it as unit U1 is equal to force into displacement. Suppose according to the question, if length and the force are increased 4 times, here F indicates force, S indicates displacement, displacement is equivalent to length, both are same here. So here suppose if it is increased 4 times. Increased 4 times, then we can write 4 times of F into 4 times of length or displacement. So we can write initial equation is u1 equal to F into S. When we increased 4 times, instead of u1 we can take u2. u2 equal to 4F into 4S. So therefore u2 is equal to 4 into 4 will be how much? 16 into u. Because you can observe here 16 into what? F into S. u2 equal to 16 capacities. What is F into S? u2 equal to 16 into u1. So when force and length are increased 4 times, then the unit of energy is increased 16 times. So option B is the right answer. Sixth question, if x equal to at plus bt square, where x is the distance travelled by the body in kilometers, while t is the time in seconds, then the unit of b is. Here x indicates distance, t indicates time. X is measured in terms of kilometers and time is measured in terms of second. Using these values, we have to find the unit of B. See here, the equation is x equal to at plus bt square. We want only the unit of B. X equal to at, x equal to bt square. We can observe only this part because we want only the unit of B. X equal to bt square. We want the unit of B. So B equal to, the equation becomes x divided by t square. B equal to, x is measured in terms of kilometer and the time is measured in terms of second square. What is the unit of B now? Kilometer per second square. So option C is the right answer. Which of the following quantities has not been expressed in proper unit? Here the 4 options are given. We have to find which quantity has not been expressed in a proper unit. The first option is torque. See here, torque is denoted by the symbol tau and its equation is given by R cross F, that is force into displacement, or we can take force into position vector, that gives torque. So torque equal to R cross F. So here R is measured in terms of meter, force is measured in terms of Newton. So we can write Newton meter. This is the unit of torque. Then second option, stress. So stress is restoring force per unit area. Restoring force is measured in terms of Newton. Area is measured in terms of meter square. So the unit becomes Newton per meter square. Then third point, modulus of elasticity. Modulus of elasticity is given by the equation stress over strain. Stress over strain equal to modulus of elasticity. Stress unit is what? Newton per meter square divided by strain. Strain indicates here increase in length to the original length or change in configuration to the original configuration. They will get cancelled. It has no unit. Strain is not having any unit, so we can write 1. So finally the equation becomes Newton per meter square. This is the SI unit of modulus of elasticity. Then fourth one, surface tension. Surface tension is given by the equation S equal to force over length. Force divided by length gives surface tension. SI unit of force is Newton and the length is measured in terms of meter. Newton per meter is the unit of surface tension. Now you can observe which quantity is not expressed properly. Torque is measured in terms of Newton meter. Yes, it is right. Stress is measured in terms of Newton per meter square. Yes, this is also correct. Modulus of elasticity is measured in terms of Newton per meter square. This is also correct. Surface tension is measured in terms of Newton per meter, but here it is given Newton. per meter square. So this is wrong. So the right option is D. Surface tension has not been expressed in a proper unit. Eighth question, if E is the charge, V is the potential difference and T is the temperature, then the unit of EV over T are as same as that of. See here, EV divided by T. E indicates charge, V indicates potential difference. So this is equivalent to electron volt, or we can express in terms of work. Right? W divided by T. Or we can write W divided by T. So here work done, you can remember isothermal process and adiabatic process in the chapter thermodynamics. So there we have the equation PV, W equal to PV divided by T. We know that equation PV equal to nRT, where R is number of mole. If number of mole is 1, we have the equation PV equal to RT. So what is the equation here? PV divided by T. So PV over R is equal to what? T. So this PV over T can be written as, observe here, in place of PV over T, I can write simply R. So here R indicates universal gas constant. We know that equation potential difference is given by V equal to W by Q. W equal to what? V into Q. W equal to V into Q indicates a charge. So we can write charge of the electron as E. So in place of VE, we wrote here W. You can observe here. In place of E into V, I wrote work done. W divided by T. Work done. Here you can remember isothermal or adiabatic process. Here we can write instead of W, we can write pressure volume PV. PV divided by T equal to what? R. Because we know this equation PV by R equal to T or PV equal to RT. So from this equation we got PV by T means what? R here. Now you can observe the given options. The first one is Planck's constant. What is Planck's constant? See here, Planck's constant relates photon's energy to its frequency. What is Planck's constant? This is a photon's energy to its frequency. Here its value, A option here. This is denoted by Planck's constant is denoted by H equal to 6.62 into 10 raised to minus 34 meter square kg per second. This is what Planck's constant. Second option is given Stephen's constant. Stephen's constant is denoted by sigma, and this is the total intensity radiated over all wavelengths increases as temperature increases. So here option B, Stephen's constant is denoted by E. E is directly proportional to T raised to 4, or we can write E equal to sigma into T raised to 4. This is about Stephen's constant. Then come to the third option. Boltzmann's constant. Here pressure volume work P and V. Pressure volume work. Here Boltzmann constant, or that Boltzmann related to temperature and energy. It is related to what? Temperature and energy. So temperature and energy, you can observe this part. Temperature and energy, W indicates work done, or which is equal to energy divided by temperature. Boltzmann constant is related to temperature and work, or temperature and energy, which is given by the value Kb equal to 1.38 into 10 raised to minus 23 meter square kg per second square per Kelvin. So this is what Boltzmann constant, which is related to temperature and energy. So here the suitable answer is option C. Option C is the right answer, because you can observe the unit of EV by T is as same as that of Boltzmann constant. And gravitational constant is denoted by G, which is related to gravitational force and the mass. But here Boltzmann constant is related to work or energy and the temperature. So option C is the right answer. Ninth question. to determine Young's modulus of a wire, the formula is y equal to F divided by A into L divided by delta L. This is the equation for Young's modulus of a wire, where L is length, A is area of cross section of the wire, delta L is change in length of the wire when stretched with a force F. The conversion factor to change it from CGS to MKS is. Here the equation for Young's modulus of a wire is given, and the equation is y equal to F over A into L divided by delta L. This is the equation for Young's modulus. We have to convert from CGS to MKS. CGS to MKS we have to convert. See here, y equal to F divided by A into delta L over delta L. L is measured in terms of meter, delta L is also measured in terms of meter. So length and the length will get cancelled. We got F divided by A. Y equal to, here F is measured in terms of dyne and area is measured in terms of centimeter square. Dyne per centimeter square. Or we can write dyne means how much? 10 raised to minus 5 Newton divided by centimeter square is equal to how many meters square? 10 raised to minus 4 meters square. Right? So 10 raised to minus 5. 10 raised to minus 4 we can take to numerator. It becomes plus 4. Remaining is what? Newton per meter square. Minus 5 plus 4 indicates 10 raised to minus 1 Newton per meter square, or you can write 0.1 Newton per meter square. You can observe we converted it from CGS to MKS system. MKS system, here we got 0.1 Newton per meter square. So option C is the right answer. 10th question, a metal sample carrying a current along x-axis with density Jx is subjected to a magnetic field Bz along z-axis. The electric field Ey developed along y-axis is directly proportional to Jx as well as Bz. The constant of proportionality has SI unit. See here. This is x-axis. Let us consider this is y-axis and this is z-axis. X, y and z-axis. Here along x-axis we can consider. You can read the question. A metal sample carrying a current along x-axis with density Jx. Here density is Jx and it carries a current, let us take it as I, is subjected to a magnetic field Bz along z-axis. Along z-axis means magnetic field is Bz. Is directly proportional to Jx as well as Bz. Here the electric field Ey is developed along y-axis. This is electric field Ey along y-axis, which is directly proportional to Jx as well as Bz. Now the constant of proportionality has unit. So according to this question, Ey is directly proportional to two terms. Which are those? Jx and Bz. Ey is directly proportional to Jx, Bz. Or we can write Ey equal to proportionality constant. We can take K, Jx, Bz, keep as it is. So this equation I wrote according to the question. You can read here. Ey developed along y-axis is directly proportional to Jx as well as Bz. So we wrote Ey is directly proportional to Jx, Bz, or we can write proportionality constant K. Now what we have to find? We have to find the unit of K. So this equation can be written as K equal to Ey divided by Jx into Bz. Ey divided by Jx into Bz. Now we can easily write their units to find the unit of K. Here I am going to write K equal to EY over BZ. I am going to write here separately EY over BZ. What is EY? EY is electric field divided by BZ. What is BZ? Magnetic field. Electric field over magnetic field. What it gives? Remember, it is equal to speed of light. What it is? It is equal to speed of light. So we can write EY over BZ means directly we can write C. Speed of light we can take it as C. EY over BZ equal to C. C indicates the speed of light. Remember, electric field lines and magnetic field lines, they are proportional to each other. They are propagating in the free space. Propagating means they are traveling with the same speed of light. Speed of light and speed of these electric and magnetic field lines are same. So we can write EY divided by BZ equal to speed of light, which is denoted by C. Then come to the term Jx. What is Jx? Jx is density. What is density? Here I can write Jx is equal to, Jx indicates current density, which is given by the equation I over E. Current over area, that gives density. So current means ampere divided by area means meter square. So in place of Jx we can write ampere per meter square. Now substitute all the values here. Ey over Bz is what? C divided by Jx, keep as it is, or we can write C indicates speed of light. Speed of light is measured in terms of meter per second divided by Jx is measured in terms of ampere per meter square, or we can write meter per second into meter square per ampere. So meter square into meter will be what? Meter cube over ampere into second. So the constant of proportionality K is having the unit meter cube per ampere second. Meter cube per ampere second means option B is the right answer. 11th question. A student measured the diameter of a wire using a screw gauge with least count 0.001 centimeter and listed the measurements. The measured value should be recorded as. See here, least count of screw gauge is given. We can take LC equal to 0.001 centimeter. So least count of screw gauge is the smallest length. So least count means the smallest length we can measure from this instrument is how much? 0.001 centimeter. So which can be measured accurately with it. So LC equal to 0.001 centimeter, or we can write 1 divided by 1000 centimeter. So you can observe after this decimal point there are 3 digits 001. So the measured value should be recorded up to 3 decimal places. So you can observe the options. After decimal point there should be 3 digits. So we can go for option D, 5.320 centimeter. So why we have to choose option D? Because you can observe the least count of screw gauge is 0.001. After this decimal point there are 3 digits. So here we have to write 5.320 centimeter because the least count means the smallest length that we can measure using screw gauge. So option D is right. 12th question. The refractive index of water measured by the relation mu equal to real depth divided by apparent depth is found to have the values 1.34, 1.38, 1.32 and 1.36. These are the measured values. The mean value of refractive index with percentage error is. We have to find mean value of refractive index and also we have to find percentage error. Yes, easily we can find mean value using the measured values. So we can write all the measured values, that is 1.34 plus 1.38 plus 1.32 plus 1.36 divided by, totally there are 4 values, so divided by 4. Sum of all the values divided by 4, that gives mean value. So mean value we will get nearly after calculation 1.35. This is mean value 1.35. Now you can observe the options. Option A and option B both are having same value 1.35. Now we have to find percentage error. So before going to find percentage error, first we have to know absolute error, mean absolute error, relative error, then we can find percentage error. So now we can find absolute error. Yes, how to find absolute error? Absolute error means mean value minus measured value. Mean value minus measured value, that gives absolute error. So mean value is how much? 1.35 minus measured values are 1.34, 1.38, 1.32 and 1.36. So we can write for the first value, let us take it as delta A1 is equal to 1.35 minus 1.34. Similarly, for the second value, delta A2 equal to 1.35 minus 1.38. Delta A3 is equal to 1.35 minus 1.32. Delta A4 is equal to 1.35 minus 1.36. Yes, now we will get the absolute errors. Delta A1 is 0.01, delta A2 minus 0.03, delta A3 plus 0.03, delta A4 minus 0.01. These are the absolute error. Now we can find mean absolute error. Mean absolute error. Yes, how to find mean absolute error? The sum of absolute error divided by 4. Remember, mean absolute error is always positive. We are going to consider mod. Mean absolute error delta A bar is equal to mod of delta A1 plus mod of delta A2 plus mod of delta A3 plus mod of delta A4 divided by 4. Now substitute all the values. Delta A bar is equal to delta A1 we got 0.01 plus 0.03. Don't write negative sign here because we are using mod. Mean absolute error is always a positive number. Plus 0.03 plus 0.01 divided by 4. So we will get mean absolute error after calculation. The answer is 0.02. This is mean absolute error. Now we can find relative error. Yes, how to find relative error? Relative error is denoted by delta A is equal to delta A bar divided by A bar. Delta A bar is what? Mean absolute error. A bar is what? A bar means mean value. Right? So now we can write delta A equal to delta A bar we got 0.02 divided by A bar is how much? Mean value is 1.35. So we will get after calculation 0.01481. This is relative error. Now at last easily we can find percentage error. Percentage error is what? Delta A into 100. That is relative error into 100. 0.01481 into 100, that gives 1.481%. This is percentage error. What is the final answer? 1.481%. 1.48%. That indicates option A is the right answer because mean value is 1.35 and percentage error is 1.48%. So option A is right. Question number 13. If the resistance R equal to V divided by I, where V equal to 100 plus or minus 5 volt and I equal to 10 plus or minus 0.2 ampere, what is the total error in R? So here we can use error in division. Arithmetic operations we can use here. This is error in division because the given equation is R equal to V divided by I. This is division arithmetic operation. So we can use error in division. So V value is given 100 plus or minus 5 volt and electric current I value is given 10 plus or minus 0.2 ampere. Using these values easily we can find a total error in the resistance R. See here, we know that error in division generally it is given by the equation Z equal to X over Y, or delta Z over Z equal to delta X over X plus delta Y over Y. This equation we can use to find error in the resistance. So Z equal to X over Y. In place of X over Y we can write R equal to V divided by I. R equal to V by I. Here V value is 100. Delta V value is plus or minus 5. I value is 10 ampere. Delta I value is plus or minus 0.2 ampere. Now substitute the values. R equal to V by I. V value is 100 divided by electric current is 10. So 100 by 10 is how much? 10 ohm. This is what? Error in division. Now we can use delta Z over Z. Therefore, delta Z over Z means we can write delta R over R is equal to delta V over V plus delta I over I. This equation we can use here. Now substitute the value. Delta R over R equal to delta V over V. Delta V is how much? 5 divided by V value is 100 plus delta I is 0.2 divided by I value is 10. Delta R over R is equal to 5 by 100 means 0.05 plus 0.2 divided by 10, that gives 0.02. By adding these values we will get the answer 0.07. But we want a percentage error because all the options are given in terms of percentage. So 0.07 into 100, that gives 7%. So this is the total error present in the resistance R. 7% means option B is the right answer. 14th question. If 3.8 into 10 raised to minus 6 is added to 4.2 into 10 raised to minus 5, giving the regard to significant figures, then the result will be. So we can use significant figures in addition. The values are given like this. 3.8 into 10 raised to minus 6 is added to plus 4.2 into 10 raised to minus 5. So what is the result? And that result we have to express in terms of significant figures. So here we can use significant figures in addition. Yes, we already know that for addition as well as for subtraction, the least decimal places we have to consider in the final result. See here, 3.8 into 10 raised to minus 6 and the second one is 4.2 into 10 raised to minus 5. So I am going to rewrite these numbers. 0.38 into 10 raised to minus 5 and the second number is 4.2 into 10 raised to minus 5. From these two numbers, first we have to find the least decimal places. The power of 10 is not considered in significant figures, leave it. Remaining is only 0.38 and 4.2. 0.38, how many digits are there after the decimal point? There are 2 decimal places. And in the second number, 4.2, there is only 1 decimal place. So 4.2, there is only 1 decimal place. Which is having least decimal place here? So 4.2 is having least decimal place. So in our final answer, the final answer should have only one decimal place. First we have to add these two numbers. 3.8 into 10 raised to minus 6, or instead of that we can write it as 0.38 into 10 raised to minus 5 plus 4.2 into 10 raised to minus 5. After adding these two numbers, we will get the answer 4.58 into 10 raised to minus 5. 4.58 into 10 raised to minus 5, but the final result should have only one decimal place. So we can write it as 4.588 is greater than 5. So the previous number is increased by 1. Instead of 4.58, we can write 4.6 into 10 raised to minus 5. So this is the final answer. 4.6 into 10 raised to minus 5 means option B is right. 15th question. A physical parameter A can be determined by measuring the parameters B, C, D and E using the relation A equal to B raised to alpha, C raised to beta divided by D raised to gamma, E raised to delta. If the maximum error in the measurements of B, C, D and E are B 1%, C 1%, D 1% and E 1%, then the maximum error in the value determined by the experiment is. First we can write the given equation, that is A equal to B raised to alpha, C raised to beta divided by D raised to gamma into E raised to delta. This is the given equation. Error in parameters. Errors in parameters is already given. We can write that error in parameters, that is B 1%, C 1%, D 1% and E 1%. These are the errors in parameters. So now we can use the equation. This is delta A over A is equal to B raised to alpha, C raised to beta divided by D raised to gamma into E raised to alpha. We can use error in exponential. Error in exponential. You can remember in general we can write z equal to x raised to n, delta z equal to n into delta x. So this equation we can use here to find the maximum error present in this given experiment. Delta A over A equal to B raised to alpha can be written as alpha into delta B over B plus beta into delta C over C plus gamma delta D over D plus delta E over E. This is error in exponential. Alpha into error in parameters is already given, delta B over B. How much error is present in this parameter? That is B 1% of error is present. Plus beta capacities, delta C over C. Here C 1% of error is present. Similarly gamma, delta D over D is how much? D 1% plus delta capacities, delta E over E. Here E 1% of error is present. Or we can write it as alpha B1 plus beta C1 plus gamma D1 plus delta E1%. This is the maximum error in the value determined by the experiment. So option D is the right answer. 16th question. The density of a cube is measured by measuring its mass and length of its sides. If the maximum error in the measurement of mass and length are 4% and 3% respectively, the maximum error in the measurement of the density will be. Yes, first we have to know what is density. Density is mass per unit volume. That is, we can write M divided by L cube. because volume is what? Length into breadth into height. So which is equal to L cube, m divided by L cube. Here the percentage error in mass and length is already given. So we can write percentage error in mass means delta m over m into 100. It is given. How much? 4%. Similarly, length is given delta L over L into 100. It is also given how much? 3%. Right? So density means it is generally denoted by the symbol rho. Rho equal to, or we can write it as rho equal to m divided by L cube. Using this equation, we can find maximum error present in the measurement of density. M divided by L cube, this is division arithmetic operation. Here we can use error in division as well as we can use error in power because L raised to 3, this is the exponential form. So I can use two arithmetic operations here, that is error in division as well as error in power. Error in division and power we can use here. Here we can write it as delta rho over rho is equal to, error in division means how to write the equation? Delta m over m into 100 plus L cube. L cube means this is the exponential form. So we can write 3 into delta L over L into 100. Now easily you can substitute the value. Delta rho over rho equal to, here percentage error present in mass is already given, that is 4%, plus 3 keep as it is. Percentage error in length is given 3%. So we will get the final answer 4% plus 3 3s are 9. 9 plus 4 will be 13%. So 13% of maximum error is present in the measurement of density. So option D is the right answer. 17th question. The diameter of a sphere is measured with an instrument having least count 0.001 centimeter. The diameter is 1.933 centimeter. The radius to correct significant figures will be, yes, least count is given, we can take LC equal to 0.001 centimeter. Then diameter is given, let us take D equal to 1.933 centimeter. We have to find a radius in terms of significant figure. Radius is half of the diameter, D by 2 means 1.933 divided by 2, we will get 0.9665 centimeter. This is the radius value. But according to significant figures, we have to express. So now you can observe least count. After decimal point, there are 3 digits here, right? So that in our final answer, the final answer should have 3 digits after the decimal point. Our final result is having 4 digits. You can observe 9665. So now we have to make a correction. Then we have to express in terms of significant figures. That means after decimal point only 3 digits should have present. So we can write R equal to 0.9665. The last digit you can observe, this is 5. Right? So 5 means we can take only the previous digit 966 centimeter. Suppose if it is greater than 5, then we can take 967. But it is equal to 5 and the previous number is even number. If it is even, so we have to keep as it is. So the final answer is 0.966 centimeter. So the correct option is B, 0.966 centimeter. 18th question. The period of oscillation of a simple pendulum is given by T equal to 2 pi root of L divided by G, where L is about 100 centimeter and is known to have 1 millimeter accuracy. The period is about 2 seconds. Time period is about 2 seconds. The time of 100 oscillation is measured by a stopwatch of least count 0.1 second. The percentage error in G is. Yes, we have to find percentage error in G. First, we can write the given equation, that is T equal to 2 pi root of L divided by G. Here L value is given how much? 100 centimeter, and it is having accuracy. How much accuracy it is having? 1 millimeter accuracy. Similarly, time period is given 2 seconds. 100 oscillations are measured by a stopwatch. Then least count is given 0.1 second. So we have to find percentage error in G value. See here, T equal to 2 pi root of L over G. This equation can be written as, I am squaring both the sides. T square equal to, we can write it as 4 pi square L divided by G, squaring both sides. Or we can write G equal to, because we want percentage error in G, so G equal to equation becomes 4 pi square L divided by T square. Using this equation, we can find percentage error present in G. Now here, first I am going to write percentage error in L and percentage error in T, right? See here, percentage error present in L is equal to, I am going to use the equation delta L over L into 100. Delta L over L into 100 means delta L value is given 1 millimeter divided by L value is given 100 centimeter into 100. So we will get the answer 1 millimeter equal to 0.1 centimeter divided by 100 centimeter into 100. So 100 will get cancelled. So we will get 0.1%. This is what percentage error in L. Similarly, we have to find percentage error in time period T. Yes, it is given percentage error in time period. So least count means here it is given 0.1, that is delta T over T divided by, how many oscillations are there here? 100 oscillations. For each oscillation the time taken is 2 seconds. 100 oscillation and the time taken is 2 seconds. 0.1 divided by 100 into 2 into 100 in terms of percentage. So we will get 0.1 divided by 100 into 200 into 100 means the final answer is 0.05%. This is percentage error in time period. We got percentage error in L as well as in T. Now we can find percentage error in G. Yes, we can write percentage error in L plus, here you can observe this equation, 4 pi square is constant, remaining is what? L divided by T square. L by T square means here we can use error in division as well as error in power. Error in division and error in power means we can write delta L over L into 100 plus 2 into delta T over T into 100. So we can write plus 2 capacities percentage error in T. Now substitute all the values. Percentage error in L is 0.1% plus 2 capacities. Percentage error in time period is 0.05. So we will get the final answer as 0.2%. So this much amount of error is present in G. 0.2% means option C is the right answer. Question number 19. A student measured the length of a rod and wrote it as 3.50 centimeter. Which instrument did he use to measure it? A student measured the length of the rod and the answer is how much? 3.50 centimeter. Which instrument did he use to measure it? Measured length of the rod is given. Let us first we can write measured length of the rod is 3.50 centimeter. So here we can use the instrument vernier calipers. See here, for vernier scale, when we are using the instrument vernier calipers, in that for vernier scale with one main scale division. For vernier scale with one main scale division is equal to 1 millimeter. Yes, you have this experiment in your first PUC vernier calipers. For vernier scale, when we are going to consider vernier scale with main scale division, this is equal to how much? 1 millimeter. Similarly, 9 main scale divisions is equal to 10 vernier scale division. So this part you can understand when you have started to use the instrument in practical. So now you can understand 9 main scale divisions is equal to how much? 10 vernier scale division. So therefore least count is equal to, we have this equation, 1 main scale division minus 1 vernier scale division. So that gives the answer 0.1 millimeter. Right? So here measured length is 3.50 centimeter. First you can go through the options. The first one is a meter scale. In a meter scale, we have only up to 1 decimal place. So this is not the right answer. Come to the second option, a vernier calipers where the 10 divisions in vernier scale matches with 9 divisions in main scale. And main scale has 10 divisions in 1 centimeter. So this is the right option. Then option C, a screw gauge having 100 divisions in the circular scale and the pitch has 1 millimeter. Then fourth option, a screw gauge having 50 divisions in circular scale and pitch has 1 millimeter. So here the right option is B because we are using vernier calipers to measure length of the rod. 20th question, a force F is applied onto a square plate of side L. If a percentage error in determining L is 2% and that in F is 4%, the permissible percentage error in determining the pressure is. So we have to find percentage error in determining the pressure. First we have to know what is pressure. Pressure means force per unit area. That is P equal to F divided by A. A indicates area. Instead of area, we can write L square because area is length into breadth, or we can directly write here L square. Now we can find percentage error in pressure. Percentage error in pressure means we can use error in division, error in exponential because the equation is P equal to F divided by L square. So we can write delta P over P is equal to delta F over F into 100 divided by L square. This is exponential form. So we can write plus 2 into delta L over L into 100. Delta P over P equal to, here the percentage error in L as well as in F is given. For F there is a 4% of error plus 2 capacities. For L 2% of error is present. So we will get 2 2s are 4, 4 plus 4 is 8%. 8% of maximum percentage error is present in pressure. 8% means option D is the right answer. 21st question, the specific resistance rho of a circular wire of radius r, resistance capital R and length L is given by rho equal to pi r square r divided by L. Given r value 0.24 plus or minus 0.02 centimeter, capital R resistance equal to 30 plus or minus 1 ohm. This is not bad, this is ohm, and L equal to 4.80 plus or minus 0.01 centimeter. The percentage error in rho is nearly. See here, resistivity or specific resistance is denoted by rho and the equation is given by pi r square r divided by L. And the value of radius, length and resistance are given. R equal to, it is given 0.24 plus or minus 0.02 centimeter. Then resistance R equal to 30 plus or minus 1 ohm. Similarly, L equal to 4.80 plus or minus 0.01 centimeter. These are the given value. We have to substitute in the given equation. Then we will find the error. So I am going to write percentage error in a rho. Rho indicates specific resistance or resistivity. So we can write delta rho over rho is equal to pi is constant, leave it. Remaining is r square, exponential form. So we can write 2 into delta r over r into 100. Then capital R plus delta r over r into 100 plus delta L over L into 100. Now substitute all the values. 2 keep as it is. Delta R is how much? Given 0.02 divided by R value is 2.4 into 100 plus delta R over R, that is 1 over 30 into 100 plus delta L over L, that is 0.01 over 4.80 into 100. Now you can calculate all these value. 16.7 plus 3.3 plus 0.2. We will get the final answer as 20%. So the percentage error in resistivity or in specific resistance is 20%. So option D is the right answer. A thin copper wire of length L meter increases in length by 2% when heated through 10 degrees Celsius. What is the percentage error in area when a square copper sheet of length L meter is heated through 10 degrees Celsius? Percentage increase in the length is given. Initially it is L meter. When it is heated at 10 degrees Celsius, there is increase in the length of a copper wire, that is 2%. So we can write percentage increase in length is equal to 2%. Then similarly, what is the percentage increase in area when a square copper sheet of length L meter is heated through 10 degrees Celsius? So we have to find percentage increase in area of square copper sheet. Square copper sheet. This is equal to, see here, area means what here? Length into breadth, or we can write L into L. L is given 2% and this is also 2%. So area means it will be double of the length. So that is 4%. So 4% of area is increased when it is heated through same temperature of 10 degrees Celsius. So option A is the right answer. 23rd question. A simple pendulum experiment for the determination of acceleration due to gravity. Time period is measured with an accuracy of 0.2% while length was measured with an accuracy of 0.5%. The percentage accuracy in the value of G so obtained is. See here, in a simple pendulum experiment, we have the equation for time period T equal to 2 pi root of L divided by G. Here we have to find percentage accuracy in G value. So we can modify this equation. Squaring on both sides, we will get T square equal to 4 pi square L divided by G. We want G value, so we can write G equal to 4 pi square L divided by G. That means here G is directly proportional to L and inversely proportional to T square. G is directly proportional to L and inversely proportional to T square. So we can find percentage accuracy in G. So I am going to write delta G over G into 100 is equal to delta L over L into 100 plus T square exponential form. So we can write 2 delta T over T into 100. Now substitute the values. Delta L over L into 100 is already given. It has accuracy of 0.5% plus 2 capacities. Delta T over T into 100 has an accuracy of 0.2%. So we will get the final answer. 2 2s are 4, 4 plus 5 will be 9. So 0.9% is the percentage accuracy in the value of G. Option C is the right answer. Question number 24. The heat generated in a circuit is given by Q equal to I square R into T, where I is current, R is resistance and T is time. If percentage error in measuring I, R and T are 2%, 1% and 1% respectively, then the maximum error in measuring the heat will be. See here, already the equation is given Q equal to I square R T, right? So we have to find percentage error in this value in Q. Means we can write delta Q over Q into 100. We have to find this is equal to I square exponential form. So we can write 2 into delta I over I into 100 plus delta R over R into 100 plus delta T over T into 100. Now substitute all the values. 2 capacities, delta I over I into 100 is already given 2% plus delta R over R into 100 is given 1% plus delta T over T into 100 is given 1%. So we will get the final answer 4 plus 1 plus 1 means the final answer is 6% is the maximum error present in the measurement of heat. 6% means option D is the right answer. 25th question. A physical quantity P is described by the relation P equal to A raised to 1 by 2 B square C cube D raised to minus 4. This is the given equation for one physical quantity. If relative error in the measurement of A, B, C and D respectively are 2%, 1%, 3% and 5%, then relative error in P will be. First we can write the equation P equal to A raised to 1 by 2, B raised to 2, C raised to 3, D raised to minus 4. And the error in each parameter is given, that is 2%, 1%, 3% and 5%. So we have to find relative error in P. So I am going to write delta P over P equal to, this equation can be written as A raised to 1 by 2 means what? 1 by 2 into delta A over A plus B square can be written as 2 into delta B over B plus C cube means 3 into delta C over C plus 4, the exponential form is what? 4. Don't write negative sign here because this relative error is having always positive numbers. So 4 capacity is delta D over D. Now substitute all the values. 1 by 2 into delta A over A is given how much? 2% plus 2 capacities. Delta B over B is 1% plus 3 capacities. Delta C over C is 3% plus 4 capacities, delta D over D is 5%. So we will get the final answer as 32%. So 32% is the relative error present in the given physical quantity. Option C is the right answer. Question number 26. In the experiment of calibration of voltmeter, a standard cell of EMF 1.1 volt is balanced against 440 centimeter of potential wire. The potential difference across the ends of a resistance is found to balance against 220 centimeter of the wire. The corresponding reading of voltmeter is 0.5 volt. The error in the reading of voltmeter will be. See here, potential per unit length. We can write potential per unit length. Here it is having potential how much? 1.1 volt divided by per unit length. Length is how much? 440 centimeter. So we will get the answer 1.1 divided by 440 is 0.0025 volt per centimeter. This is what? Potential per unit length. But here for the length, it is given for length, let us take L is 220 centimeter. Then voltmeter reading is for 220 centimeter. So what is the reading on the voltmeter? Voltmeter reading we can write 0.0025 into 220 centimeter, that gives the value 0.55 volt. So here for unit length we got the value 0.0025. This is per centimeter. For 220 centimeter means multiplied by 220 we will get 0.55 volt. Now we have to find error in the reading of the voltmeter. So what is the reading shows in the voltmeter? 0.5. So we can find error is equal to 0.5 is the reading in the reading of the voltmeter minus 0.55. That gives the answer minus 0.05 volt. This is the error in the reading of voltmeter. What is the answer? Minus 0.05 volt. So option D is the right answer. 27th question. In a vernier calipers, 10 smallest divisions of the vernier scale are equal to 9 smallest division on the main scale. If the smallest division on the main scale is half millimeter, then vernier constant is. See here, according to this question, it is given 10 vernier scale division. 10 vernier scale division is equal to how much? 9 main scale division. That is 10 VSD is equal to 9 MSD. Or we can write 1 VSD equal to how much? 9 by 10 MSD. So vernier constant means we can write 1 main scale division minus 1 vernier scale division. 1 main scale division means how much? 1 minus 9 by 10. This is what main scale division. So this is equal to 1 by 10 main scale division. 1 minus 9 by 10 is how much? 1 by 10. 1 by 10 main scale division is equal to 1 by 10. So main scale division it is given half millimeter. Half millimeter means 1 by 2. So we will get the answer 0.05 millimeter. So 0.05 millimeter, option C is the right answer. 28th question. A vernier caliper has 20 divisions on the vernier scale which coincide with 19 on the main scale. The least count of instrument is 0.1 millimeter. The main scale divisions are of least count LC, it is given 0.1 millimeter means 0.1 divided by 10. We can convert into centimeter, 0.01 centimeter. We know that vernier constant means what? 1 main scale division minus 1 vernier scale division. 1 main scale division minus 1 vernier scale division, it is given 19 and 20, they coincide. 20 division on vernier, 19 divisions on main scale. So we can write 19 by 20 main scale division in place of 1 vernier scale. Or we can write 1 minus 19 by 20 main scale division. So vernier scale, here it is given, that is 0.1 millimeter. This is the least count. So here we can write 1 by 10 is equal to 1 minus 19 by 20 is 1 by 20 main scale division. Or we can write 1 main scale division equal to 20 by 10. 20 by 10 means how much? 2 millimeter. So 1 main scale division equal to 2 millimeter. So option C is the right answer. Question number 29. The least count of stopwatch is given 0.2 second. The time of 20 oscillation of a pendulum is measured to be 25 seconds. The percentage error in the measurement of time will be. Least count for stopwatch is given LC equal to 0.2 seconds. So we have to find percentage error in the measurement of time. So we can write percentage error in time interval, that is delta T over T into 100. Delta T over T. Delta T value is how much? Least count of the stopwatch is 0.2 divided by time period for 25 oscillations. That is time for 20 oscillation is 25 seconds into 100. So the final answer is 0.8 seconds. Option C is the right answer. 30th question. A screw gauge has 200 equal divisions marked along circumference of the disc, and one full rotation of the disc advances on the main scale by 0.05 centimeter. The least count of the screw gauge is. Remember, least count of the screw gauge is determined by the formula least count LC equal to pitch divided by number of divisions on circular scale. Using this equation, we can find least count of screw gauge. Pitch is given 0.05 divided by number of divisions on the circular scale is 200. 0.05 divided by 200 means 2.5 into 10 raised to minus 4. So this is the least count of the screw gauge. 2.5 into 10 raised to minus 4 centimeter means option A is the right answer.